Hello to everyone and welcome to part 6 of this video series. For the part 1 to part 5, I'm going to put a link in the description box which is for from 2016 to 2021. So for those interested, I'm going to put a link in the description box, and also I'll put a card above there for those interested in watching the video. So we're going to be answering 2015 question 4 in this video, and if we look at the question, it says that we have been given our dy all over dx to be v minus x. So we are going to name this our equation 1. We have also been given our differential equation, and we are going to name our differential equation equation star. Now we have been told to transform to a differential equation this, where v is a function of x. So it's very clear we'll be differentiating the function with respect to x because we want to express our v in terms of x. So we're going to look for the second derivative of this function. So it will be d squared y all over dx squared will simply be equal to, now this will be dv all over dx minus 1. So this is our equation 2. Now we want to transform this to this, but we already know that our dy all over dx is v minus x. So we're simply going to, anywhere we see dy dx, we simply replace it with v minus x, and anywhere we see d squared y over dx, we'll replace it with dv all over dx, so that at the end we have something like that. So substituting equation 1 and equation 2 in equation star.
What the hell happened in here? Hey, who did this?
Something attacked us. Irving. He got away. It was a setup.
A setup? What is this?
It's data regarding the deal. I downloaded it from their computer. Oh, you gotta get it to HQ.
Hey, hang in there.
I saw someone, but they ran away.
Kurt, do you copy? We got the data, but Alpha Team is down. Irving got away.
Roger. Relay the data from the vehicle at the storage facility.
Copy that.
So putting this in equation star, we're going to get x squared minus 1 times our equation star says that we have dv all over dx minus 1 minus 2x into our dy over dx is v minus x. So this will simply be equals to x squared plus 1. So what we want to do is we simplify it, and we simplify it, and we make the v all over dx subject. So to do that, we are going to open our bracket here. So to open our brackets there, we are going to have x squared minus 1 times dv all over dx, now minus in bracket x squared minus 1 minus 2x v plus 2x squared. So this will be equals to x squared plus 1. So we have kind of like expanded this function, so we are going to see the things that can easily cancel out, and then so here we have x squared minus 1, we're not going to expand this dv all over dx. So minus x squared plus 1 minus x squared plus 1. So here we'll have minus 2xv plus 2x squared equals to x squared plus 1. So it's time to cancel out. We see there are some common things. So we see that 1 is going to cancel out with 1, and here we have 2x plus this is going to give us x, so it will go away with that, so we'll be left with minus 2xv. So here we are left with x squared minus 1 dv all over dx to be equals to 2xv, right, when we send that that other way. So this implies that our dv all over dx will simply be 2xv all over x squared minus 1. So now let's check if this is the same as what
What the hell is that?
I think that's what got Alpha Team.
Fall back!
the equation that was we were asked to transform. Great. So we have already transformed our differential equation to this. They said, hence, find the solution in the form y equals to f of x. So here we want to look for a solution in the form y equals to f of x. So what we need to do here is just to separate our variables. So what we need to do here is just to separate our variables, and to do that we're simply going to take dv all over. So if this this v comes down here, we'll be left with v, and if the x goes up there, we'll be left with 2x dx all over x squared minus 1. So if we take now our integral sign, what do we notice? We notice that this will give us the ln of the absolute value of v, to be equals to, we say that the derivative, the denominator is exactly equal, the derivative of the denominator is exactly equal to the numerator. So this will be ln of x squared minus 1, now plus our constant k. Very great. So so the next thing we need to do is, we have our dy dx was v minus x. We know that our dy all over dx was v minus x minus x. That's our dy dx was v minus x. So what does this really mean? This means that our v is simply dy all over dx plus x. It's very clear. So if we keep that here, so first of all, if we want to take if we want to make V subject, what we will simply need to do is we are going to have V will be equal to x squared minus 1 times, let's say t. We have this initially. Now our V is dy all over dx plus x to give us t into x squared minus 1. Now we know that the condition given to us above said that our dy all over dx, the conditions above said that dy dx is 1, while y is negative 2 and x is 2. Our dy dx is 1, right? So it means that dy all over dx is 1, y is negative 2 and x is 2, just to check, and x is 2. Okay, great. Now if we apply that here, because we've noticed that our v is dy dx, all of that. Okay, now if we apply it here, we're going to have 1 plus our x is 2, so this will give us 3 t into 2 squared will be 4 minus 1, so this implies that 3 should be equals to 3t. So this implies that our t is 1. Great, t is 1. So now it means that our v will simply be x squared minus 1. But what do we know? We know that v is dy all over dx plus our x. So this will simply be x squared minus 1. So this means that our dy all over dx will simply be x squared minus x minus 1. Therefore, our dy will be x squared minus x minus 1, all of that dx, so that when we integrate this, we're finally going to have y to be equals to x cubed all over 3 minus x squared all over 2 minus x plus a constant k, because the limits of the limits of integrations were not given. So okay, that is it for this video. And thank you guys very much for watching. Please, if the video was helpful, give a like, and if you want to receive more videos like this in other topics, then subscribe to this channel so that whenever videos are uploaded, you will be notified. Thank you very much, and see you in the next video.